Now we're gonna learn about inverse matrices. If A and B are two square matrices, right? The keyword here is square matrices. You have learned before the definition of square matrices, such that A multiplied with B is equal to B multiplied with A and equal to capital I, where capital I is the identity matrix. Then matrix B is the inverse of matrix A, and in the same time also matrix A is the inverse of matrix B. The inverse of matrix A is donated by A inverse. Same also, the inverse of matrix B is donated by B inverse, like this. That's how you write the inverse matrix. For your syllabus, you will learn there are two methods to obtain inverse of matrices. The first method is adjoint method. The adjoint method, you must remember the formula A inverse is equal to 1 over the determinant of matrix A. You multiply it with matrix of adjoint A. And then the second method is by using elementary row operations. Finding inverse by using adjoint method. The inverse of a matrix A is donated by A inverse equal to 1 over determinant of A times with adjoint A, given that the determinant A must not equal to 0, because you cannot divide anything with 0. Do you understand that, everyone? One more thing that you need to remember is A inverse is not 1 over A. Please remember that. Now, we go to the properties. If the determinant A is not equal to 0, so A is a non-singular matrix, meaning that inverse matrix exists. If the determinant A is equal to 0, A is a singular matrix, so inverse matrix does not exist. Now we go to the explanation on what is adjoint matrix. Adjoint matrix is, let C equal to Cij be the cofactor matrix of A. You have learned before the cofactor matrix. Adjoint of matrix A is defined as the transpose of the cofactor matrix, that is like this. Adjoint, we write it as ADJ, capital A, that particular matrix. And then in the same time, we can also write it as capital C power of T, or cofactor transpose. Okay, we look to the example, the first example. Given matrix A 1 2 3 T 2 4 1 1 3, find the adjoint A. So what we need to find is first find the cofactor of A, the matrix cofactor. So I write in the matrix form like this. Okay. Now you have learned before this what is matrix cofactor. you take each element. For example, for the first element 1, you close the first row and the first column, and then you should get the determinant there for A, D and B, C there. So here is 2, 4, 1, 3. And then for it here, 3, 4, 1, 3. Three, 2, 1, 1. Then we move to the second row. 2, 3, 1, 3. 1, 3, 1, 3. 1, 2, 1, 1. Lastly, we go to the last row. 2, 3, 2, 4. 1, 3, 3, 4. And then 1, 2, 3, 2. Then don't forget to put the symbol because we are dealing with cofactor. So plus, minus, plus, minus, plus, minus, plus, minus, plus. Understand? Then we solve here by using the formula of determinant AD minus BC. Here, the first row should be 2 times 3 minus 4 times 1. So 6 minus 4. And then here, negative 9 minus 4. Here, positive 3 minus 2. For the second row, negative 6 minus 3. Positive 3 minus 3. Negative 1 minus 2. Okay. And then for the last row, positive 8 minus 6. Negative 4 minus 9. And then plus 2 minus 6. Then last, you will get a matrix of cofactor 2, negative 5, 1, negative 3, 0, 1, 2, 5, negative 4. Okay, do you understand how to get a matrix of cofactor first? Alright, if you understand, now we go to the next step, which is to find the adjoint. As you have learned that adjoint A is the matrix of cofactor A that we transpose. So, which is a 2, negative 5, 1, negative 3, 0, 1, and 2, 5, negative 4. We transpose. So, adjoint A is 2, negative 3, 2, negative 5, 0, 5, and 1, 1, negative 4. That's all. Do you understand how to get an adjoint? Alright, for finding inverse of 2 by 2 matrix, let's say capital A, which is the matrix A, is a 2 by 2 matrix A, B, C, D, then the A inverse is given by the formula of 1 over AB minus BC times with at the row 1 small d negative B, and the row 2 is negative C and A. We go to the example. Find the inverse for A 3154. So by using the formula, the A inverse should be 1 over AD minus BC D negative B negative C and A. Then so AD minus BC will be 1 over 3 times 4 minus 5 times 1 times it with 4 negative 1 negative 5 and 3. Understand? And then we proceed 1 over 12 minus 5 times 4 negative 1 negative 5 and 3. Then what will happen, it should be 1 over 7 4 negative 1 negative 5 and 3. And lastly, you need to multiply all the elements in the matrix with the figure in front here. So it will be 4 over 7, negative 1 over 7, negative 5 over 7, and 3 over 7. That's how you get the inverse of matrix A. For example 3, show that A 2, negative 4, negative 1, 2 has no inverse. So how do we show a matrix has no inverse? Is by using the formula of inverse. As you can see, the formula for A inverse for 2 by 2 is 1 over AD minus BC D negative B negative C and A. AD minus BC is actually the determinant of matrix A. So, how do you know a matrix has no inverse? Is when the value here is equal to 0, because 1 over 0 is not exist. So for this question, how do you show matrix A has no inverse? By proving that the determinant you get 0. So there is no inverse for this matrix. Alright, first of all, you need to find the determinant of B. I will be using the first row. So that's why I take the first plus 1, the determinant of 2, 2, negative 1, 0. And then it should be negative 3. So negative 3. Zero, 2, negative 2, 0. and then plus 2, 0, 2, negative 2, negative 1. Okay, then 0 plus 2 minus 3, 0 plus 4 plus 2, 0 plus 4. And then you simplify, you get negative 2 minus 12 plus 8 equals to negative 2. Understand, everyone? Alright. Now we go to the second question, which is find the cofactor of matrix B. Okay, the cofactor you have learned before. First, is right. Now we take for the first row 2, 2, negative 1, 0, 0, 2, negative 2, 0, and then 0, 2, negative 2, negative 1. For the second row, 3, 2, negative 1, 0, 1, 2, negative 2, 0, 1, 3, negative 2, negative 1. And for the last row, 3, 2, 2, 2, 1, 2, 0, 2, 1, 3, 0, 2. Okay, now don't forget, because it's a cofactor, you need to put all the symbol. Understand? Okay, we solve the matrix. So we got 2, and then for the third row, okay, understand? Then you will get the answer 2, negative 4, 4, negative 2, 4, negative 5, 2, negative 2, 2. Understand? Alright. The last question, they ask for, hence, find the inverse of matrix B by using adjoint method. Okay, as you know and as you have learned before, B inverse, by using adjoint method, the formula is 1 over determinant of B adjoint B. So what is adjoint B again? Adjoint B is the cofactor of B that has been transposed. So we find the adjoint B first. The transpose of the cofactor B, you will get 2, negative 2, 2, negative 4, 4, negative 2, and 4, negative 5, 2. Last but not least, you can get B inverse is equal to 1 over negative 2 times it with the adjoint. 2, 4, 4, 4, negative 5, 2. And then don't forget to multiply all the elements in the matrix into the matrix again. 2, negative 2, 1, negative 2, 5 over 2, and negative 1. Okay, that's how you find the inverse matrix by using adjoint method.